There are two examples left in this section, examples H and I. And this is a really good review of what we've been talking about so far in regards to both exponential and logarithmic equations. Okay, so imagine you saw this on your homework, or you saw this on a quiz or an exam even. You know, how would you approach both of these problems? Okay, first thing you need to think about, okay, you're going to look at your equation and you're going to ask yourself, is it exponential or is it logarithmic? Okay, so if it's exponential, your approach is going to be this, okay? First thing you're going to try is to isolate the exponential piece, so the base in the exponent, okay, and attempt to get the same base on both sides, okay? And then if you can get the same base on both sides, then you set the exponents equal to each other, and then you go from there, okay? If you cannot get the bases equal to each other, then you need to get logarithms involved, okay? If you, on the other hand, are dealing with a logarithmic equation, the only method we know so far is to apply the arrow method, all right? So let's give these a shot. Okay, so in example H, you have log base 5 of x squared plus x plus 4 is equal to 2, okay? This is a logarithmic equation, okay? You physically see a logarithm present, okay? So the only method we know so far, and like I've been telling you, we're going to learn more methods for more complicated problems in section 6.6. But the only method so far that we know is to do the arrow method, okay? You can translate this using the definition of a logarithm. This means that if I take the base and raise it to this power, I'm going to get this quantity, okay? So this is going to tell me that 5 squared is equal to x squared plus x plus 4, okay? Notice the logarithm is gone now, okay? It's going to leave us with an equation that we should know how to solve, okay? So 5 squared is 25, and if we look at this, we realize that it is quadratic. The highest power of x is 2, okay? So to solve a quadratic equation, you have two options. You either need to factor or use the quadratic formula. Regardless of which option you choose, one side has to be 0 before you start. Okay, so we need to move the 25 over. So we're going to get 0 is equal to x squared plus x minus 21. Okay, and if you're going to go the factoring route, you would factor the non-zero side. And if you're going to go the quadratic formula route, you're going to apply the quadratic formula to this. Okay, I'm going to go with the quadratic formula here, okay? So a is the number in front of x squared, so it's 1. B is the number in front of x, so it's also 1. C is the constant, so it's going to be negative 21, okay? And now I'm going to plug into the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, okay? So if we plug in our a, b, and c, we are going to get negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 21 all over 2 times 1. Okay, so now we need to simplify. Okay, so we're going to get negative 1 plus or minus, let's figure out what's underneath the square root. 1 squared is 1. Negative times negative will give us positive. 4 times 1 times 21 is going to give us, let's see, I think it's 84. Yeah, 84. Okay. All over 2. Okay. All right, so this is going to give us negative 1 plus or minus the square root of 85 all over 2. Okay, so this is your exact answer. Okay, you have two solutions, one from picking the plus in the middle and one from picking the minus in the middle in the numerator. Okay, so this is your exact solutions. Okay, so remember we need to get a decimal approximation. Okay, so I'm going to go ahead and write out the first exact answer is negative 1 plus the square root of 85 divided by 2. Okay, and then I'll go ahead and get a decimal approximation for that one. Okay, square roots, if you don't know them off the top of your head, they're going to be irrational. All right, so let's go ahead and try to plug this in. Turn this light off, maybe that will help. Nope. All right, so let's see here. We're going to get -1 plus the square root of 85. Okay, I'm going to hit enter. That's going to give me the numerator. And then if I divide by 2, so just hit the division key, it'll divide the numerator by 2. Okay, so we're going to round it to 3 decimal places. So we're going to go ahead and say this is 4.109. The 7 is going to bump the 9 up. So this is going to be approximately 4.110. Okay, and then the other solution will come from picking the minus sign in the middle. So we're going to get -1 minus the square root of 85 all over 2. Okay, so now we're going to pop this into the calculator. Okay, same kind of method. So you're just going to do -1 minus the square root of 85. Enter. That's the numerator. Then divide that by 2. Okay, so this one, if we round it to do 2 decimal places, the approximation is going to be -5.110. Okay. All right. So those are your 2 approximate or decimal approximations. Okay. So I'll put that here. Okay. Decimal approximations. Okay. So that's how you solve this first logarithmic problem. All right. So now we will move on. Okay. And we'll go back and try to solve this problem. Okay. I'm going to go ahead and make a little partition here so we don't run into the work from part H. All right, so here we go. All right, when I look at this equation, okay, there is no logarithm present. I notice that the x is in the power, okay? So this is an exponential equation, okay? So our first attempt is going to be to try to get the bases the same, okay? Before you can do that though, okay, you need to isolate the exponential piece. I need to get the base with the exponent by itself, okay? That is this piece. 10 is the base, and then 2x minus 7 is the exponent. That's what contains the x, okay? So we need to isolate that. All right, so the first thing we're going to do, let me rewrite the problem here. We have 8 times 10 raised to the 2x minus 7 power plus 1 is equal to 4, okay? We want to isolate the 10 raised to the 2x minus 7, okay? To do that, we are going to first subtract 1 from both sides. Okay, so we're going to get 8 times 10 raised to the 2x minus 7 power is equal to 3. Okay, almost there. We've got to get rid of the 8. Since we're multiplying by 8, we're going to undo that by dividing by 8. Whatever you do to one side, you have to do to the other. Okay, the 8's will cancel on the left. That is going to leave you with 10 raised to the 2x minus 7 power is equal to 3/8. Okay, so now the base and the exponent, that exponential piece, is isolated. Okay, so at this point, can you make the bases the same? The base on the left is 10. The base on the right is 3/8. There is no way I can write 10 as a power of 3/8 or vice versa, 3/8 as a power of 10. So there's no way we're going to get the bases to be equal on both sides. Okay, so we're going to have to get a logarithm involved. Okay, so remember when we did, I think it was examples F and G, they involved E. So we used natural log because E and natural log are inverses of each other. Okay, here we've got 10. Remember, 10 is our, base of our exponential here. So remember, log is base 10. So you should use log here, log. Okay. All right. So what we're going to do is take the log Remember, that's base 10 of both sides. Okay, whatever you do to one side, you should do to the other. Okay, and I'm putting parentheses here because you're taking the log of that whole quantity, just to clarify. Okay. All right, so took the log of both sides. Again, we're using log because it is base, it's a base 10 logarithm. Okay, the base of your exponential is 10. Okay, so you want to use a base 10 logarithm so that they will cancel each other out. Okay, so I'm going to go back and show you the property we learned when we were looking at common logarithms. Okay, when we were looking at common logarithms, if you have right here, if you have the logarithm of 10 to a power, since log base 10 and 10 are inverses of each other, they cancel each other out and just leave you with the exponent. Okay, so back to the equation, that's what we have on the left side. I have log and 10 right next to each other, so they cancel out and the exponent is going to come down. Okay, so we're going to get 2x minus 7 is equal to the log of 3/8. You have to keep the log on the other side. There was nothing to cancel it out. Okay, log of 3/8 is going to be some crazy decimal. Just leave it alone. Okay, going forward, this is linear now. The highest power of x is 1. Okay, so you just need to isolate the x. Look at this number or look at this quantity, log of 3/8. It's just a number. Okay, so to isolate the x, we are going to add 7 to both sides. So you're going to get 2x is equal to the log of 3/8 plus 7. And then you will divide both sides by 2. Okay, so the exact answer is the log of 3/8 plus 7 all divided by 2. Okay, and you need to leave it like that. Okay, it looks crazy and complicated. Leave it alone. Okay, so now we will type it into the calculator to get a decimal approximation, because remember, this is the exact answer. All right, so for our decimal approximation, I'll put it over here. So the decimal approximation, all right, I'm just going to type this guy into the calculator exactly like I see it pretty much. Okay, you have to use log here. Okay, so we're going to get the log of 3/8. Now close the parentheses because that is what you're taking the logarithm of. Okay, and then we're going to add 7 to that. Okay, that's going to give you the numerator, and then hit the division key to divide by 2. Okay, there's your decimal approximation. We're going to round to 3 places after the decimal point. So you've got 287. You've got a 0 after the 7, and so we will just, keep it the same. We won't round up. So my decimal approximation is going to be that x is approximately 3.287. Okay. And like I said, we will look at more complicated exponential equations and more complicated logarithmic equations in section 6.6. But now we're going to move on to section 6.5. It's going to teach us 3 important properties that we need in order to tackle those harder questions in 6.6.